Hello everyone. So in the last lecture we have seen some of the characterization instruments that we use for electrical device characterization or electronic sensor characterization, and we have seen how we can use those devices for say IV curve measurement, or for example measuring voltage from certain source, how we can actually capture signal in a certain instrument, and also briefly described the operation of the instrument. Just to make it clear, there are multiple similar instruments available that has even higher specification. For example, if you talk about digital multimeter, as I mentioned in the previous class, that in the undergrad lab you also have a digital multimeter which is very small, in mostly in the yellow and black color, which is very small, and this also can measure voltage, current, resistance, so on and so forth. But the digital multimeter that we have seen in the last lecture is a benchtop one, and the difference between this digital multimeter and the one that we usually use in say undergraduate lab or postgraduate lab, the handheld one, is the specification. The specification of the benchtop one that I just meaning I showed in the previous lecture is of higher specification. So the specification is quite high for that instrument. For example, the current range, the voltage range, the resolution, the resistance range, and the functionality of the instrument. For example, you have a dedicated software with this benchtop system. You can record the response using that software. You can actually also control the device using that software, which is an additional kind of functionality of this particular instrument. And if you use the benchtop instrument, you possibly will get more options, to measure the voltage, and as I have said, the resolution would be much better. When I say resolution, for example, the handheld one that we usually use, the general purpose one, possibly have a resolution of say few millivolt in the voltage measurement part, but the one that we are using in the benchtop digital multimeter that we used in the previous lecture possibly has a resolution which is much lower, maybe in microvolt or even nanovolt. I need to check that, but that is what the differences are. You will get even better multimeters available in the market. So every day these specifications are, they are getting improved. So people are coming up with very new type of multimeters with even higher specifications. So what I have just shown, or what I showed in the last lecture, is an example. So it's not that this is the only multimeter available. So this is just to give you an idea that you may get many other similar type of multimeters, but the use of the multimeter, or how we can actually utilize the multimeter for electrical characterization, is something that I just wanted to show. Even in today's lecture, we will introduce three very important but expensive instruments. For example, electrochemical workstation, vector network analyzer, and solar simulator. All three instruments are very, very important, and all three instruments are used usually for electrical characterization of different devices. Apart from that, we also have many other instruments. So I won't be able to cover all the instruments. I mean, even in my lab, you will find there are parametric analyzer, or in the department lab, in this institute, there are many similar instruments available, but I won't be able to give you a demonstration of all these instruments, but I just want to demonstrate or give an visual tutorial kind of thing for important instruments. For example, there are instruments like parametric analyzer, probe station, impedance analyzer, ferroelectric measurement setup, so on and so forth, so many. So, I won't be able to provide demonstration of all these, but in this lecture I will show you the demonstration of three very important instruments like electrochemical workstation. This is an instrument which people usually use for electrochemical characterization. For example, you want to do an cyclic voltammetry, if you want to do an chronoamperometry, if you want to do say even simple impedance measurement. So, similar type of characterization you can do with an electrochemical workstation. This particular instrument is highly customizable. So, you may find that a similar instrument is kept elsewhere which has maybe higher capability than what I am going to show you, or you may find a similar instrument kept in some other lab which has lower functionality, because this instrument is very much customizable. So, based on your need they can add different modules and your instrument will start functioning accordingly. Then we have vector network analyzer. Vector network analyzer is a very important device for RF characterization, RF device characterization, RF circuit characterization, and the one that I will show in this lecture is an handheld one, as a pretty small one, 2-port vector network analyzer. But you may also find vector network analyzers that are benchtop and have higher specification or maybe lower specification. It depends on what is the model that you purchase and how do you want to customize the instrument. So, you will find different other types of vector network analyzer also, but the one that I will show is I mean the purpose of showing that instrument is to show you how we can use this instrument. So, the usage and application remains the same, maybe the specification, the look and the form factor will change based on the model you purchase or based on the company you choose. Then I will also show you a solar simulator, which is again a very important instrument for optoelectronic characterization, where you have a box. Inside that you have a light source, so you can shine your sample with light of various wavelengths. The idea is, if you want to characterize say a photodetector, a photodiode, a solar cell, then you can put this particular sample or the sensor inside this solar simulator and can do characterization at various wavelengths, or in fact you can simulate the typical outside sun that you get usually in a day, and there are different standards. So, that is why it is called solar simulator. So, you can simulate the solar environment, and I will also explain that when I discuss about this instrument or when I give you a demonstration of this instrument. But nevertheless, this lecture will again cover few more instruments and I hope you will like that. So, let us go to the lab and start the demonstration session, and we will meet after that demonstration again to summarize this lecture. So, this is another instrument which is an electrochemical workstation. So, this particular instrument is basically used for chemical characterization, not chemical characterization, but I mean is chemical sensor characterization, and this particular instrument has 4 different terminals. So, you possibly have seen electrochemical sensors in various literature or in various places. Usually those sensors have 3 different terminals. One is counter electrode, reference electrode and working electrode, and then you have ground electrode also. So, that is why this particular instrument has 4 different terminals, and apart from that you also can do electrochemical characterization or electrochemical response characterization using 2 terminals as well. Now this particular instrument mostly are used for chemical sensor characterization. This could be semiconductor based chemical sensor characterization as well, which involves some electrochemical process. Now this instrument also has a software which is given here, and if you go to the setup and the technique of this particular software, you will get a list of characterization that is possible using this particular instrument. Now you can see the names over here. You can do cyclic voltammetry, you can do linear sweep voltammetry, you can do chronoamperometry, you can do chronocolometry, you can do square wave voltammetry, you can do bulk electrolysis with colometry, so on and so forth. AC impedance, impedance with time, impedance with potential, and other different experiments or other different characterization. Now this particular instrument is highly customizable. So when you buy this particular instrument, you can customize it according to your needs. In some of the similar instrument, you may find that all these options are not present. This possibly because the instrument is not customized for all those measurements. You may also get some additional option in this particular instrument in some other places. The reason being, probably that instrument is customized for those additional experiments. Hence, this instrument will have different types of techniques available in different software platform. Now in this case, in order to demonstrate this instrument, what we have done is, we have connected an LDR again with this particular instrument, and we will now see how the impedance is changing, say, with potential. So this is the LDR which is connected with the instrument using these two wires, and then we selected the impedance versus potential in the software and press OK. Now in this case, we have to give the initial value and the final value. Let us give the initial value is 0 and the final value as 2. So the voltage sweep is between 0 and 2 volt, and the increment is 0.05 volt. So this particular measurement will start from 0 volt, end at 2 volts, and increment in each case is 0.05 volt, and the other values are also mentioned here. Now you just set this, press OK, and you can run the experiment. So when you run the experiment, your analysis will start. You can see from the instrument that there is no display present in this instrument. So whatever value you will get in this software interface. Now because LDR is a resistive device, you can see that with potential the impedance is more or less constant. You don't have any phase which is more or less 0. And now if you cover the LDR surface with your finger, you can see the impedance value has increased now. And the moment you remove your finger from the surface of the LDR, the impedance value has fallen down to the value that it was showing before. So in this particular case, the LDR was in dark condition because you have covered the surface of the LDR with your finger. So it is basically a dark condition compared to the ambient light condition. The moment the LDR is exposed to light, the impedance value that you are getting is much lower than the one that you received in dark condition. We already know the principle of LDR. When light falls on top of LDR, more carriers are available on the surface, and that is why the resistance is lower. When you cover the LDR, number of carriers are comparatively lower, and hence the impedance is, or resistance in this case, is quite high. So this is the instrument, and you can use this instrument for various purposes, even for IV measurement as well. So as I mentioned, however, this particular instrument is mostly for electrochemical characterization, and the techniques that are available in this instrument, especially for the one that we have in this lab, is also being shown. So now we have a very important and a complex device, in fact a measuring equipment, The name of this measuring equipment is vector network analyzer. This particular instrument is used to characterize different RF signals or characterization of different RF devices. This particular instrument has two different modes. One is it can detect normal RF signals, or it can characterize different RF devices. At the same time, it also has a spectrum analyzer inbuilt. So you can get this particular device, the vector network analyzer, in different form factors. Again, you will get in different shape. There are some vector network analyzers that are benchtop, which look similar to the devices that the benchtop devices that we have shown, little bigger. But this particular device is useful in characterizing RF devices like, say, antenna or various other RF devices. There are two ports. This is one port, this is another port. This particular VNA has two different ports, two ports. One port we are currently using, and just to give you an example, what we have done is we have connected this probe with one of our flexible antennas. So we develop flexible antennas also. Just to give you an idea, what we have done is we have connected this with an flexible antenna that is connected over here using an SMA connector. And now you can see that you get the S11 parameter in this particular VNA. So you can measure the return loss of the antenna using this VNA. You can measure other parameters also, other S parameters also using this VNA. This is just for the demonstration purposes. I am not going very deep into this particular instrument, or I am not going in a deep discussion related to this particular instrument, because currently this is not at the core of this particular course. Basically, this particular instrument, I would say a deep discussion related to this particular instrument is out of the scope of this course. But nevertheless, I just wanted to give you an idea about an instrument like vector network analyzer, and that is why I am currently showing this vector network analyzer. This vector network analyzer is handheld, so you can carry it and can do other measurements also. At the same time, you can characterize different flexible antennas like this. You can characterize any sorts of antenna, any sorts of RF devices. So there are multiple characterizations that is possible using this particular instrument. This instrument has a range of frequency. So different instruments come with different range of frequencies. So one can be, say, 0 to 6 gigahertz, 0 to 3 gigahertz, 0 to 20 gigahertz, so on and so forth. Based on that range, basically you can then decide which RF device you want to measure or you want to characterize, because if the operation range of that particular RF device is not falling within the range of this instrument, then this instrument cannot characterize that particular device or that particular antenna. So just to give you an idea, this is how a flexible antenna looks like. You can also characterize rigid antennas, because we develop flexible sensing antennas and flexible antennas. I am showing you this particular antenna, and you can see there is an SMA connector at the bottom. So this SMA connector, then you can connect with this probe in order to do this characterization. Nevertheless, when you have this kind of devices, you need to actually calibrate these devices with different calibration kits. So this is one of the calibration kit where you have open circuit, short circuit and load calibration. Before using this instrument, you have to calibrate the probe or the instrument using the calibration kit provided by the company. This instrument is very much useful, as I have said, for RF device and RF sensor measurements. This is one of the instruments where we can do optoelectronic measurements. This particular setup is known as solar simulator. If you look at the setup that is there inside, you can see a light source on top, and then you have sample holders where you can keep your samples, say somewhere here. So you can illuminate different light of different wavelengths from this particular source, and then you can shine your samples with those wavelengths. once you shine the light of different wavelengths on the particular sample, you can then do IV characteristics, or you can measure the IV characteristics using source meters. So this particular instrument is only to illuminate the sample with different lights, meaning lights of different wavelengths, but ultimately you have to do the characterization, the IV characterization or any sorts of characterization with some other instrument. So if the characterization is IV characterization, you can use source meter. We already have discussed what is source meter. So you have two terminals and you can connect the terminals with this particular sample, and then you can shine the light and get the reading from that. Now, in order to control this light and light intensity and light wavelength, it is connected with one controller, and this controller has an screen. So in short, this particular thing is connected with one controller. So this is the instrument which controls the light intensity, and we can record the light related or not record, meaning control the light related aspects using this particular instrument. Now this instrument has a software which is shown over here, where you can select LEDs of different wavelengths. So it is already written over here, the wavelength. So you can select the wavelength, and then you can select the LED power, and you can actually calculate the global intensity, LED power, so on and so forth, and then accordingly you can shine the light inside this particular box. Now one thing that one needs to remember in this case is, this is not only with different wavelengths, you also can create environment which is similar to the sunlight. For example, if you want to do an experiment with solar cell, you want to do that experiment in an environment where you can simulate the solar sunlight, that is the sunlight coming from the sun. And for that purpose also you can use this particular instrument. This instrument can create environments which is similar to sun in the daylight, and there are different matrices which provides us that what kind of sunlight is actually this particular simulator is simulating. So it's kind of simulating the actual environment inside this box. Now if you look at this particular box, this is actually creating a dark environment inside this particular box, in order to ensure that ambient light is not interfering with this light related experiments, because there are ambient light. Whenever you do some experiments, there will be ambient light like this lab environment. There are LEDs from where you get different kind of lights. So in these optoelectronic experiments, these ambient light should not interfere, and that is why the entire setup is kept inside this box, which is a black box kind of thing. This ensures that ambient light has no interference. Okay, and we also do different experiments of sensors, like if you develop a photo detector, you can actually illuminate the photo detector with different wavelengths, light of different wavelengths using this particular instrument. If you develop a solar cell, you can do experiments in different solar environment, and you can create this using this particular software. So this is very accurate, and we can use it for optoelectronic related applications. We can use it for solar cell related application. We can use it for photo detector application, photodiode application, so on and so forth. So this is again an characterization instrument which provides different kinds of light of different wavelengths, and definitely you need additional instrument to characterize the, say, current, voltage, so on and so forth. Whatever you want to characterize, you need to attach that particular instrument with this. This instrument will only provide lights of different wavelengths. So in this lecture, we have seen various instruments again. So the idea was to provide you a very brief demonstration of different instruments that can do electrical characterization. In the previous lecture, we have seen digital multimeter, source meter, mixed signal oscilloscope, and I I think we also have seen some other instruments. So the idea was to provide you some idea about the instruments related to electrical characterization. In this particular lecture also we have seen vector network analyzer, we have seen solar simulator, and in the beginning we have also seen LCR meter. I think LCR meter we covered in the last lecture, and in this lecture we have covered few more instruments. And with this we will now conclude the demonstration of different electrical characterization instrument session. We can show more instruments, and we can also give you very brief demonstration of other instruments as well. But as I have said, that the purpose of this particular course is to provide some experimental exposure of different electronic devices or electronic sensors or device related sensors. So the instruments that are absolutely needed for those characterizations are already being demonstrated or are already being introduced with you in these two lectures. So we will conclude this session for this course, session of demonstrating or introducing instruments. We will demonstrate other instruments maybe in some other course in future, some online course where we will see how to also characterize different sensors in details, and we will also see how we can actually use those instruments for various purposes. So with this I am concluding this particular lecture. We will meet again in the next lecture with maybe some theoretical concepts. We will do more experimental sessions in the coming lectures, and we will now start characterizing different electronic devices and electronic components. With this, let us conclude this lecture. We will meet again in the next lecture. Thank you.